Okay, so we've been learning about energy in Chapter 5 and changes in energy and how that's associated with the chemical reaction. And you can do certain calculations to determine the changes in energy. So the first one would be to find Q. Q is your heat energy, okay, is heat energy. All right. So the equation that you'd be given for Q is that Q equals mc delta T. M stands for the mass, C stands for specific heat, and delta T stands for change in temperature, which is T final minus T initial. Okay, so this is going to allow me to find, based on the specific heat, the amount of energy that is associated with this chemical reaction. Okay, so I'm running a chemical reaction and I measure the temperature change, and that will tell me the amount of energy that was required to change the temperature of that substance by a degree Celsius based on a specific heat. Okay, so this answer will be given in joules. So Q will equal the joules of energy, or calories, joules or calories. Okay, and then you often need to convert that to kilojoules. Now the other thing you have to be careful about with Q is if you measure Q for a substance directly, so if you measure the change in temperature of a piece of metal directly, then your Q is the sign of, whatever you calculate for Q, that's the sign of the Q for that substance. However, if you carry out a chemical reaction in water, okay, then water is your surroundings. The chemical reaction is going on inside of the water. So I measure the temperature change of the water, and that's my Q for the water. But I don't want to know Q for the water. I want to know Q for the system under study, so I have to change the sign of Q, right? So that's the other thing you have to be aware of. Q of the system is equal to the negative Q of the surroundings. So if water is your surroundings, then the Q of your system that's under study is actually the opposite sign. So if your temperature change is positive, then the Q of the system is negative. If your temperature change is negative, that will give you a negative Q. Then your Q of the system is positive. You just simply have to change the sign. Okay. So that's what you need to be aware of with Q. Now delta H is the enthalpy. Okay, and enthalpy can be calculated in a couple of ways. First, delta H, the enthalpy, equals the kilojoules per mole. How do I find kilojoules? Through Q. Q calculates kilojoules. And then if I know the amount of moles of the substance, then I simply divide it by the moles, and that'll be my kilojoules per mole for that substance. Okay? Delta H can also be products minus reactants. This is for delta H of formations. Okay? So delta H of formation of the products minus delta H of the formation of the reactants. This is given data. It's given data from a table, or from, in the question they'll tell you the delta H of formation of this is this, the delta H of formation of this is this. Okay? So, but what you have to do or realize is that the delta H of formation that you're using has to be multiplied by the coefficients as well. Because those delta H of formations were obtained for every 1 mole of that thing. So if you have a chemical equation and you have 2 moles of something in that chemical equation, then the delta H of formation that's per 1 mole needs to be multiplied by 2, so you can have it for every 2 moles instead of just 1 mole. Okay? So, does anybody have, I know some of you have your homework. Maybe we could look at an example of that on the homework. Yeah, let's see it. So one thing you have to realize about a combustion reaction is that that means with oxygen.
Alright, so one of these, I guess, is what kind of stuff on it.
Okay, so you have mercury oxide is decomposed into mercury plus oxygen. Okay, and that's O2. Okay. First thing I have to do here is I have to balance this, okay? So they didn't give me this reaction. I came up with it because they said mercury oxide is decomposed into mercury and oxygen. So that's how I know what the products are. So now I have to balance this chemical equation, okay? And they told me that when 18.5 grams of mercury oxide decomposes, it releases the delta H equals 7.75 kilojoules. The energy, and it says the energy absorbed. So absorbed means positive or negative delta H. Positive. This is an endothermic reaction. It requires 7.75 kilojoules of energy to decompose that mercury oxide. So it is an endothermic reaction. It has to absorb energy for the decomposition of this. Okay? Okay, so in this question, they specifically want to know that's how much energy is evolved. What is the standard enthalpy of formation? Whoops, I'm reading the wrong question. What is the standard enthalpy of formation of mercury oxide? So what is the enthalpy of formation of that? So this equation is written in the wrong way for it to be for the formation of mercury oxide, right? They're telling me the decomposition. So 2Hg plus O2 produces 2HgO. Delta H equals negative 7.75 kilojoules. Okay? Now, this is for 18.5 grams. So 18.5 grams gives me that much energy released. They want to know how much energy is released for every 1 mole because delta H of formation is in kilojoules per mole for every 1 mole. So first thing I have to do, 18.5 grams converted to moles. Okay? And once I find the moles here, go away. I can then take my kilojoules right here and divide it by my moles here, and it will tell me the kilojoules per every 1 mole. Excuse me, hold on. Okay? Yes, that's right. Okay? That's going to tell me the kilojoules for every 1 mole of this. Okay, any questions so far? Okay, so if I produce 18.5 grams of mercury oxide, you just convert that to moles so you can find the kilojoules per mole. Okay? So, delta H is formation. I know there's a question on here that deals with delta H of formation. Okay, so here they're telling me, I can't see the subscripts on here. Does somebody else have another copy of? Yeah, you have it. Sorry. Okay, so for okay, so for example, here they're telling me that the standard enthalpy of formation of C2H4. Okay, so that's what I want to find. And this is what I'm given. That the heat of combustion means what? It means you're reacting it with what? Oxygen. So the heat of combustion of C2H4, okay? Anytime you react a hydrocarbon with oxygen, the products of that reaction are carbon dioxide and water. Okay? So we want to find the delta H of formation for this. Okay? And delta H of a reaction is equal to the delta H's of the formation of the products minus the delta H of formations of the reactants. Okay? So, once again, I need the data from the table or wherever. And then in the question, they tell me the delta H of formation for carbon dioxide is negative 393.5. The delta H of formation for water is negative 285.8. And these are kilojoules per mole. Okay? Who can tell me what the delta H of oxygen is? They didn't give it to me. It's 0. Good. The delta H of oxygen is going to be 0. They didn't give it to me because they didn't need to, because they assume you understand that if something's in its elemental form, its delta H of formation is 0. Okay? All right, so this is the oh, and I'm told that the delta H of this reaction is negative 1411 kilojoules per mole. So how am I going to solve for this? Yes, that's the very first thing I have to do. Okay, because this is not a balanced chemical equation. Okay, so now that I have a balanced chemical equation, what do I do?
You multiply by the coefficient.
Okay, these all have to be multiplied by their coefficients and added together on the reactant side, and then this is my X. That's what I'm looking for, right? So now once I find this, I can plug it in right here and solve for the delta H of this. Okay? So simply I have to subtract that from negative 1,411. And it will tell me the delta H of formation of C2H4. Okay? Okay, so delta H of formations, that's the other way you can find it, delta H of a reaction. So through calorimetry you can do it because you find Q and then divide by the moles. You can then do it through the delta H's of formation from table data. The last way, we have another example here, C plus O2 to produce CO2. H2 plus 1/2 O2 to produce H2O, and then CH3OH plus 3/2 O2 to produce carbon dioxide plus 2H2O. Okay, so this is the other way, is that they give you the delta H of reactions for each of these, delta H here is equal to negative 393.5. Delta H for this one is negative 285.8. And delta H for this one is equal to negative 726.4. Okay? And those are all kilojoules per mole. Now, the question is saying, calculate the standard enthalpy of formation of liquid methanol. This is methanol. Okay, they tell you that's what methanol is. And this is the following data that we have. So that means I want to find the delta H of formation of methanol. I need to get it all by itself and have just one of it. Okay? Because if I have two of it, then that's the delta H of formation for two methanols, and then I would have to divide by 2. But if I get it all by itself, then what I calculate will be the delta H of formation of methanol. So, first thing I have to do, this cannot be a reactant, it needs to be a product. Because I want to find the formation of methanol, so I need to flip this. Okay? So now I'm going to write it as CO2 plus 2H2O produces CH3OH plus 3/2 O2. Okay? But what does that do to my delta H? Makes it positive. Okay? All right. Now, I want to get this all by itself. So I look and I see carbon dioxide cancels. Okay? Water, I have 2 of them here. So to cancel the waters, I'm going to try to get 2 of them on this central reaction as well, so I can cancel them. So I'm going to put 2 there. This becomes 1, and this becomes 2. Cancels. Okay? What am I left with? I have carbon plus 2H2. And look at my oxygens. Okay? I'm going to rewrite this as 1.5, right? So I have 1.5 and 2. So what am I left with? I'm left with 1/2 O2. Produces CH3OH. Okay? And I got methanol all by itself. Okay, there's no carbon dioxide or waters over there. Everything canceled on that side. So I'm good. All right? So what did I need to do to the delta H of that middle reaction? I need to multiply it by 2, right? It's 2. So I'd have to multiply that by 2. And then this is going to tell me the energy, the delta H of formation of CH3OH. Okay? All right. So you simply add. So those are the 3 ways that I can find delta H's. Yes? To get the answer? You mean look it up in the table? I don't know if it's the same or if they, but I guess it should be if that's in your table. But this is how they want you to do it. They want you to do it through Hess's law. They want you to find the delta H of formation. And if you're on a test, you don't have that table data, this is how you would have to do it, because you wouldn't have that compared to. You'd have to do it through Hess's law. What's that? You won't have a table. You won't get the delta H of formations. No, you'll be given only in individual questions. They'll give you the delta H's that you need. Like on this question, they wouldn't give you that. Okay. Let's look at another one really quick. Now the other thing you have to understand is that how to use these delta H's as kind of conversion factors. So here's one, calcium oxide solid plus H2O, liquid, produces calcium hydroxide. Okay, delta H of this reaction is equal to negative 64.8 kilojoules per mole. Okay, and the question is, how much heat would be liberated when 7.15 grams of calcium oxide is dropped into a beaker containing 152 grams of H2O. Okay. So right now we can see the energy for the delta H of this reaction is negative 64.8 kilojoules. So if I produce 1 mole of calcium hydroxide, according to this balanced chemical equation, okay, then I will release negative 64.8 kilojoules per mole. How much energy is released if I start with 7.15 grams of calcium oxide or 152 grams of water? How am I going to figure this out? What's that? Okay, convert them to moles and then do what with them? That's right. That's a good first step. Okay, so, well, actually, since this is all 1 to 1 to 1, okay, the stoichiometry here is 1 to 1 to 1, right? So you're right. All I have to do is really convert these to, you have to figure out which one is what? Limiting. Which one's limiting? Okay, whichever one is limiting determines what? How much product you make. That's going to determine how much energy is released in this reaction. So whichever one's limiting, that's how many moles are being used in this reaction, right? And then I simply have to use this as a conversion factor. So whatever my moles are, moles, x moles, and I want to figure out how many kilojoules of energy is released, then I just say there's negative 64.8 kilojoules for every 1 mole, and I convert it. The moles will cancel. I'll be left with the energy, kilojoules. So my delta H is acting as a conversion factor. So once I figure out which one's limiting, and I figure out how many moles are participating in the reaction, if it was 1 mole, I would produce this, 64.8. If it's 0.5 moles, then it would be half of this, right? If it was 2 moles, it would be double that. So that's what you're trying to find. Okay? How many moles are participating in the reaction? And you have to figure out which one's limiting to be able to do that. Okay? Okay, so here's another example of something like that. C plus O2 produces carbon dioxide. Delta H equals negative 393 kilojoules. Excuse me. Okay, how many grams of carbon must be burned to release 275 kilojoules of heat? Okay, here's my balanced chemical equation. It's 1 to 1 to 1, right? And I want to know how many. So 1 mole of carbon produces negative 393 kilojoules of energy. So how much carbon is required to produce 275 kilojoules? What am I going to do?
Divide 275 by negative 393.
Okay, so I'm going to use my delta H as a conversion factor again, right? Kilojoules to moles. I want to go to the moles from the kilojoules, right? There's negative 393 kilojoules for every 1 mole. So my kilojoules is going to cancel. This is going to tell me the amount of kilojoules that is, the number of moles that I would need to burn in order for this to release 275 kilojoules of energy, right? But that's not what they want. They want the answer in what? How many grams? So then, after I have it in moles, I can convert it to grams of carbon, because this is moles of carbon. I can convert it to the grams of carbon, and that'll be my answer. Okay? Okay, so that's how I'm going to use these delta H's. I'm going to use them as conversion factors. I'm going to calculate them from other reactions if I add them up through Hess's law, or I'm going to take products minus reactants if it's the delta H's of formations, that sort of thing. Okay? All right, I don't want to monopolize all of our time on chapter 5. Oxidation. Oxidation numbers.
Which one's getting oxidized? Well, yeah.
Okay, so which chapter are we in for oxidation? Chapter 4?
Yeah.
Okay. All right. That's you. Okay, so K3P plus O2 produces K3PO4. So we want to identify what has been oxidized, what has been reduced, right? Okay. So first off, what is the oxidation state of potassium? What's its oxidation number? +1. What's the oxidation number of phosphorus? -3, right? Okay. What is the oxidation number of oxygen? 0. It's elemental. So it's 0. What is the oxidation number of potassium on the other side? It stays the same. It didn't change. Because this is ionic over here, K3P, a metal and a nonmetal, right? It's ionic compound, so we can predict the charges. Potassium is +1, phosphorus is -3. Okay? On the other side, it's also ionic. We have a polyatomic ion, PO4, and a K3. So potassium stayed the same. It's at +1. It's not part of the oxidation reduction reaction. Potassium is a spectator ion. It's not doing anything. Okay? All right. What about phosphorus now? What is the oxidation number of phosphorus after oxygen gets added to it? Okay, so here we have oxygen. Let's start with oxygen. That's better, right? What's the oxidation number of oxygen? Not anymore. -2. Oxygen almost always has an oxidation number of what? -2. That's one you can trust, you can count on. I can count on oxygen. Its oxidation number is -2 unless it's all by itself as oxygen. Unless it's O2. Excuse me. Okay? But otherwise, it has an oxidation state of -2, or if it's a peroxide, like H2, O2, now it's -1. Okay? But those are the only exceptions to hot oxygen. All right? -2, oxygen has an oxidation state of -2. So overall, those 4 oxygens are giving me how many negative charges? -8. So phosphorus has what oxidation state? Good. So +5. Because I have 3 positive charges from the potassiums. And I have to balance out -8 charges. So that means phosphorus has a +5 oxidation state. So what was oxidized? Remember, oxidation is loss. So that's right. Phosphorus lost electrons. It went from -3 to what? +5. How many electrons did it lose? 8. So we can account for those 8 electrons that it lost, right? All right, so phosphorus lost 8 electrons. It went to +5 from -3, so it is oxidized. What is reduced? Oxygen is reduced because it gained electrons, right? So what is the oxidizing agent? What is the reducing agent? Good. Okay? So that's how I'm going to identify the oxidation reduction of this reaction. So you first have to be able to identify their oxidation numbers. Yes?
So is it always the one that's being oxidized is going to be the reduction? Or,
Whatever's oxidized is the reducing agent as the reactant. So reactants are always the agents, and these are what are oxidized and reduced. Okay? That's how you'll identify them. Okay, so let's look at this one. So this has a +2. Well, it's a +1 because it's potassium. Oh, sorry, you want to balance it. Did I not balance it? Sorry. Okay. But honestly, the balance doesn't really matter with oxidation reduction. It's not gonna affect the oxidation numbers or what was oxidized or what was reduced. But it's always good to have a balanced reaction. I agree. Okay, so here we have +1 for potassiums, +1 over here, and +1 over here. Okay, so potassium is not changing oxidation state. Iodine is 0 here because it's all by itself. Okay. Oxygen is -2 here, and it's -2 here. So what's changing oxidation state? Sulfur. Okay? So this is -6. We have a +2, so that leaves what? +2 here. This is negative 12. We have a plus 2. And that leaves what? It's 5? Oops, I'm sorry. That's not right. Just give me the fraction. It's like 2.5? 2.5? 2.5? Isn't it? Okay. So, even though it's a fraction, the basic idea here is that it's increasing, right? So, this is a plus from 2 to 2.5. What's that?
How'd you get 2.5?
Because you have 10 charges that you need, negative 10 charges that need to be balanced, because I have negative 12 from the oxygens, a plus 2 from the potassium. So that's 10 left over. So 10 divided by 4 is 2.5. Okay? So it's increasing in its positive character, which means what? Loss or gain of electrons. Okay. Oxidation is loss. It's losing electrons. So this is oxidized. Reduction is gain. What got reduced? I'm sorry, I shouldn't have wrote that. But what? Not the oxygens. The oxygens stayed the same, right? All the way across. Negative 2 on one side, negative 2 on the other side. What got reduced? Good. So reduction is gain. Iodine was reduced. Iodine was reduced. So it went from 0 to negative 1. Here it has a negative 1. So what is the oxidizing agent? Iodine. Oxidizing agent. What is the reducing agent? Reducing agent. Sulfur. Okay? So that's how I'd identify these. If you take Chem 2 Lab, you're going to actually look at this reaction in Chem 2 Lab. Okay. All right. Any other questions about that? Okay, and by the way, on chapter 7 and 8, drawing the structures. So I'm just going to pick another 4 from that for the final. Maybe not 4, maybe just 2. I'll decide. I'll decide later. But I'm going to pick another couple of them for the final. Okay. So if you, I have them graded. If you want to come get it, I can go back to my office. I was going to bring them with me, but I forgot them. They're just in my office. So if you want it, so you can look over it, you can just, you can come, I'll walk over to my office after class and give them to you guys, whoever wants it, okay? But yeah, you might want to, I mean, it's just, some of you did very well on that, but some of you were struggling with some of it. But I mean, you have it's all right there on that key. Just study that key, study that homework assignment, and I'm just going to take from there. It's not going to be a surprise. Okay. So those hopefully are easy points. Okay. So for those of you that did well on that was hopefully an easy 16 points that you could get there. Okay. All right. Somewhere around, I can't remember, 65 or range-ish, something like that.
Oh, we just have one period to get.
No, you have 2 hours 45 minutes. So for those of you that usually get out of here and go somewhere, realize that the day of the final, you're going to be here a lot longer. Okay, you're going to be here till 10:45.
Do you open the door early like you do for tests?
Yeah, as soon as I get everything together, sure, I'll come in. Yeah.
Can you go over just the naming ionic and covalent compounds?
Sure. Okay. Okay, so how would I name the first one? First I need to identify whether it's ionic or covalent, right? So is the first one ionic or covalent? Ionic. How do I know? Starts with a metal. Okay, metal, non-metal, it's ionic. Okay, so what's the name of it? Calcium sulfide. I don't need to use prefixes because it's ionic. When do I use prefixes? When it's covalent, only. Okay? I only use prefixes when it's covalent because ionic compounds, you don't have to use prefixes. You can always determine the formula from the charges of the compounds, of the elements in the compound. Okay? So, there's no need to tell me the prefixes. Okay, so we have calcium sulfide. Okay, what's the name of this one? Phosphorus trichloride. How did I know to use prefixes? Covalent. How do I know it's covalent? Two nonmetals, no metal, two nonmetals. Okay? Let's hold off on that one. Let's go here. It's ionic. Nickel chloride is mostly correct, but if you choose that answer, it's incorrect. Nope, not that. It is an ionic compound, so I don't use prefixes. What am I missing? Parentheses. Good. Nickel 2 chloride. Nickel 2 chloride. Come back. Transition metal, because it's a transition metal. That's exactly why. Okay?
If it's in the first two rows,
You don't have to say that for those. Those, we know what those charges are. But this nickel could have multiple charges, so we need to state the charge except for which three? cadmium and zinc. +2, +2, +1. Okay? That's what their charges are always. Okay? Al is 3 plus, so we don't have to say it for that one either. But anything after the first two columns except for Al and those three, you have to state the charge of the metal. Yes? Okay, good question. So chlorine has what charge? Chlorine I can predict from the periodic table. -1. There's two of them. So that's a -2 charge. That means the nickel must have a +2 charge. So it's nickel 2. Okay, or you could switch the charge back up. Okay, so in this case that works. Okay, how about the next one? Good. Iron 1. Phosphate. PO4 is a polyatomic ion, right? Not for iron. You have to put the 1. Because it could be iron 2 or iron 3. What's the name of the next one? Good. This is -2. This must be +2. So this is iron 2 oxide. Okay? You can't switch back up on that one. All right? So you have to be careful. All right, let's try the next one. That last one.
Manganese to carbon.
Okay, almost. It's not manganese 2, it's what? Not 1. 4. Because carbonate has what charge? It has a -2 charge. So if I have 2 of them, that's -4. The manganese must have a +4. This is +4. Okay? So those are the things that you need to be careful of. All right? I think that's about pretty comprehensive for naming what you need to watch out for.
So a lot of it going to be multiple choice or like these kind of
Could be multiple choice. Just like all your tests. In fact, you might see questions from your old tests. It's possible.
Is there any way we can get access to our tests to review them? Or
If you come to my office, that's the only way.
Do you think you would be able to unlock the previous homeworks so we can see what we did wrong? Because that's my big issue is I never know what I did wrong. I know I get the question wrong. I don't see what the right answer is, so I
Yeah, I could probably do something like that. Just send me an email about it, so I can remember to do it. I'll look at the settings. I don't recall what the settings are. Sure. Okay. Naming acids. Okay. So if it's a binary acid, okay, then you start it with hydro. So if there is no oxygen in the acid, you start it with hydro. And then you just say, so this is a sulfur acid, H2S. So I say sulfuric hydro sulfuric acid. Hydro, what's the next one? Hydrophosphoric acid. The last one, Sienna Cyanide. close. Yeah. Hydrocyanic acid. So you start with hydro, you end it with ic, acid. Hydroic acid, if there's no oxygen. If there is oxygen, then I have to say ic, or I don't use hydro, first off, no hydro. And I say ic if it's an ATE8 ion. If it's an ite, then I say us, O-U-S. Okay? So how would I name the first one? Ic is for 8. Us is for ite. Okay, so this is going to be an ic acid, right? Because PO4, that's phosphate. So that's phosphoric acid. No hydro. Here, I have hydrophosphoric acid, H3P. Here, I have phosphoric acid because it's an 8 PO4 ion. How about this one? Because PO3 is what? Phosphite. PO4 is phosphate. PO3 is phosphite. So it would be phosphorus acid. H2SO4. Sulfuric. H2SO3. Sulfurous acid. HClO4. Say it again. I think I heard it. What was it? Not hydrochloric, that's HCl. Hydro if it doesn't have oxygen. This has oxygen. Chloric is mostly right, but this is, what is the ion here? Is it 8? Is it just 8? This is chlorate or what? What is it? This is chlorate, so this is chloric acid. Perchloric. This is peric. This is perchlorate. So it's peric acid. Perchloric acid. What's this one? Chlorus. What's this one? Nope. Still has oxygen. If it was just HCl, it would be hydrochloric. So ClO2 is excuse me, chloride. ClO is hypochlorite. So what's the name of the acid? Hypochlorous acid. Hypochlorous acid. Okay? That's how you're going to name acids. Yes.
To review the net ionic equation, the example replacement.
Okay. Okay, so if I have this reaction, I can predict the products of this reaction to be sodium nitrate and silver chloride. These are aqueous. The question is sodium chloride a precipitate or is it a aqueous compound? So you go to your chart, right? You'd be given the chart. You could look at it, and the chart would say chlorines are insoluble, except when they're with mercury, silver, and lead. Okay? So this one is a solid precipitate. So the ionic equation here is Ag plus NO3 minus plus Na plus Cl minus produces Na plus NO3 minus plus AgCl. Solid. The rest of these are all aqueous. Okay? How do I find the net ionic equation now? Eliminate your spectator ions. So the things that don't actually participate in the reaction, you get rid of them. And you get silver plus Cl minus produces AgCl solid. So this is the only reaction that actually took place. This is my net ionic equation.
How do you know which ones don't take place?
Okay, so you see how sodium and nitrate are broken apart over here? So that means they're broken apart over here too, so you eliminate them because they didn't actually do anything. They just remained dissolved on one side and they're still dissolved after the reaction took place. So they didn't do anything, so you can eliminate that. But you see how sodium chloride actually came together and it's not broken apart? So that means the silver and the chlorine came together and stayed together. So that's how I know what to eliminate, the things that broke apart and stayed apart. Okay?
And if it has three, instead of two on the left, it's the same thing, right? You can see which ones.
Yeah. Yeah, if it has three things, then you still break everything apart. You just see what forms a solid product. If there's any two ions that can come together, they will find each other. They will come together and precipitate. Everything else will just be eliminated. Okay, so actually what I want to do, I brought the computers in because I want you guys to take the intercourse survey if you haven't done that already. So if you haven't done that, go ahead and log on. You've been sent an email from the school asking you to do it, so just find that email, take it. You can take it on your phone too if you wanted to. But just please, it's really very valuable to me to have your guys' feedback. So please, if I don't give you a chance to do that, usually I end up with like 2 or 3 people that only do it. And then that's a whole class worth of people that I miss an opportunity to hear their feedback.